Hello, everyone, and welcome to today's session. On behalf of everyone at Rev.io, I'd like to thank you for joining us today. Today, Tim McLean from thinQ will be discussing how next-generation AI is transforming voice communications. Without further ado, I'd like to introduce Tim. Tim McLean, Marketing Director at thinQ and Rev.io partner, is a technologist at heart with more than 25 years of internet startup experience. Tim loves using technology to help businesses solve problems and grow bottom lines. As a lifelong learner, Tim has contributed to 4 internet startup launches and spent his early career as a TV and newspaper journalist, also boasting long marketing management stints at ProQuest and NetCertive. Now I'll turn it over to Tim.
Delaney, thank you very much. I want to say a big thank you to the entire team over at Rev.io. Rev.io and thinQ have been partners for quite a while, and just want to say a big thank you, not only for that relationship, but also the opportunity to get in front of all of you and present a little bit about a topic that I really enjoy. I kind of get a thrill out of talking about it because, I've had the chance to work with a couple products that sort of gently fall into the category of using a flavor of artificial intelligence to solve real business problems. And that's one reason why I moved over here to thinQ a little bit over a year ago, and love to get out and talk to folks like you guys on the line about how artificial intelligence can help solve a real business need or business needs at your companies. And by the way, the original title of this presentation was Artificial Intelligence's Role in the Future of Voice, but I really should have named it AI's Role in the Present of Voice, because whether we all know it or not, a flavor of AI is actually is currently active in a number of the voice solutions that are out there, including, of course, the one here at thinQ. And I really want to show you guys some fascinating examples of artificial intelligence being used in some high-tech products, and then, of course, lead us to a discussion of how it's making phone calls more intelligent and helping us save money, get better quality on those calls, and just have a better experience for our customers and our partners as we handle their voice communications. So I'd love to throw this out because we may or may not know it, but we today are living in an artificial intelligence economy. And AI is showing up in more and more products and day-to-day interactions with the real world and in our businesses. One of the best examples is, of course, Tesla. Tesla, a great American, business story, now, as you can see on your screen, has fully autonomous driving capable vehicles available today. Of course, they have not been licensed to run on outside of some test tracks out there. And of course, we're looking here in Northern California. This car is completely driving itself. And actually, you may or may not be aware, my brother actually has a Model 3, but every Tesla made in the last 2 years, which I didn't know this, it actually comes standard with the advanced hardware that's capable of providing full autopilot features and full self-driving capabilities in the very near future. So even if you buy the car, you don't pay them the extra $6,000. All the technology is sitting in the car. It's literally sending a code over the internet to the car when you pay that money, and it turns those features on, which is very interesting. So what's interesting is, guys, is that today, fully operational Tesla cars and long-haul trucks are making trips, of course, on certain approved routes as we speak. Right now, today, they're on the road driving as we speak. And what's going to be really interesting, again, as a product, we now will have access to a vehicle where all you need to do is get in, tell your car where to go, and it'll take you there. In the very near future, if you happen to purchase a Tesla vehicle, all you're going to need to do is get into the car and literally tell the car where to go. And if you don't say anything, the car's going to look at your calendar and it's going to take you there, basically the assumed destination or just home if nothing is on the calendar, which is fascinating. Your Tesla's going to figure out the best route. It's going to navigate the streets even without lane markings. It's going to manage those complex intersections with traffic lights, and it's going to handle, densely packed freeways, moving at high speed. And when you arrive at your destination, you simply step out at the entrance and your car will enter park mode. It'll find a place to park, it'll park itself, and when you're ready to get back in the car and go back where you came from, you just tap your phone and the car will literally drive itself back to you. And the question is, which I think is a fascinating story, that's all real technology that exists today that's going to become kind of a standard part of our lives here very soon. The question is, how does a Tesla do it? And that's one reason why I actually found this very recent video that shows how this flavor of artificial intelligence works for a Tesla. And by the way, if you take a look at the screen closely, it's amazing how much data that we can see, and I'm sure there's a lot more that we can't see that's being recorded and monitored by the software. But literally multiple computers are receiving input from a myriad of sensors and cameras. It's making decisions about how fast to go, what to avoid, all the rest. In fact, I love this example here because here we are, we're in a Tesla self-driving and it's following a fire truck. And you notice at one point when we come to an intersection that a car actually cuts right in front of us. And the Tesla doesn't even miss a beat. It stops early, it sees the car coming, it marks it, and then it allows the car to continue right in front of us and go about its way, which is pretty amazing. So what I want you guys to take away from this is that the Tesla is not artificially intelligent. It's not. But it's been programmed, and it's continually reprogrammed with updates from Tesla headquarters to better understand, using all of its sensors and cameras, what's going on. It's taking in this data that's continually refreshing itself, and it's making decisions to keep the driver safe, pedestrian safe, and all the rest of the cars on the road safe, and also, of course, follow all the relevant speed limits and traffic laws that are going on. So again, we're not talking about a sentient computer here. We're talking about a flavor of artificial intelligence that involves ingesting data, in this case in real time, and then making decisions based on it of how fast to go, all those different things, keeping everybody safe. So this is AI powering sort of next generation transportation, and it's available as we speak. Next, I love this example too. It's robotic surgery. So this isn't necessarily a computer controlling what's happening, but it's using, again, machine learning and some other software to make it possible for a surgeon to be anywhere in the world, use a myriad of different tools that collects inputs of what's going on during the surgery, and allow the surgeon to do remote surgery from anywhere in the world. And this is something that's becoming more and more commonplace, especially in areas where, hospitals are going away. Their doctors are needed. They're in short supply, and we can actually use the internet, connect through these intelligent systems to do all different kinds of surgeries. And there's more and more procedures being added to the list, every year. Next, and you guys may have seen a news article about this week. But this is Boston Dynamics, and they've made a whole range of these kind of semi-autonomous, again, machine learning-powered robots. And these are being planned to be used in a myriad of ways. Everything from, clearing, bomb disposal, those kinds of things. Remote security folks out there, putting these out, around large areas and monitoring areas. There's a whole bunch of different ways that each of these different types of Boston Dynamics robots are going to be used. And now there's one that you and I can actually buy. If you guys like Mythbusters, I would look up, Boston Dynamics and Mythbusters. A couple of the guys on that show actually bought one and actually turned what you're looking at here, it's yellow instead of gray, turned his into a rickshaw driver to drive him around. So what's interesting is you'll notice that this is, these robots are very good at taking in the data around them for perfect balance. These robots can jump really far. They can climb up surfaces in some cases, and they're actually being used as in lieu of kind of the dumb little boxes you see in warehouses. Instead of something like that, there'll be something that actually has legs and arms that can walk around a warehouse, pick up boxes, pick up pallets, and move them around. And again, it's all these sensors, it's all these different computers taking in data, changing the behavior of the robots, and of course, using that data over time to make them even smarter and more well-balanced, because again, it's this data that's being collected and aggregated and used to make the solutions better, but also the outcomes better. And that's really what we're talking about today. So if we talk about artificial intelligence, by the way, I think it's a big misnomer. When you start to talk to people about AI, they say, look, this is not Skynet. This is not a fully intelligent system. Why are you calling it artificial intelligence? Well, if you look around the horn, AI is actually kind of a multi-tiered term that's used for everything from, again, chatbots to next generation cloud robotics to cybersecurity, even virtual companions, neuromorphic computing you see up there on the left. So there's a lot of different sort of flavors of AI that, we're just getting away from a super intelligent machine that can replicate human behavior. It's not what we're talking about today. So if we take another step deeper, this is really what I'm talking about is, there are systems that can enable computers to mimic human behavior, but really let's take one step down to machine learning. So machine learning is AI techniques that give computers the ability to learn without being explicitly programmed to do so. So that's why something like a Tesla car is using machine learning, because it's taking in data, real-time data from what's going on around it, and it hasn't been programmed, right, to sort of be smart. It's just being told exactly what happens when a certain set of parameters occur, and as that data comes in and those events occur, it's going to respond accordingly. So it's all programming. And also, sometimes people call this layer sort of adjacent to it predictive analytics. So if I can predict that something's going to happen, if I can quantify that and predict it and store it in a computer, I can have the computer respond in an appropriate way. So really, and I think what's really fascinating is if you look at the tick marks across the bottom, machine learning as a subset of AI has really been around since 1980, 1981 or so. And again, we're talking about predictive analytics, machine learning, which is really extrapolating data from data to more intelligently process a routine or process based on historical context. That's the one that I love the most. So the more data you have over a longer period of time, the more you can make something smart about how it's going to react in the future. And that's going to lead us into a big discussion about how this is impacting voice in just a few minutes. But first, I think a really good example of showing you machine learning affecting us on a day-to-day basis is speech recognition. I don't know about you guys, but I'm amazed in a very short period of time how much better my iPhone and my wife's Android phone has gotten better at turning our speech into text, in recent years. And really the question is, why and how did this happen as a result of, machine learning and AI? Well, if we take a look at this slide, guys, it's really, there were four factors that led to the perfect storm of better speech recognition. And the first thing was, until the cloud came along, there was not enough data to really allow a system to evaluate human speech to get better and better at, interpreting what people are talking and turning it into text. We are all probably, familiar with, Dragon Speak and those other early speech recognition programs that really weren't all that great. It's because we had to wait for the system, right? The company that made that program to continually download updates to improve, their software to, better turn speech into text. But nowadays, we've got a cloud and we've got billions of people with smartphones who are using this technology. So all the providers, all the software providers are using all of that data so they can make their software continually better. And the updates happen in real time without us doing anything. We don't have to wait for that to happen. There's a much larger quantity of data that allows them to make the software smarter. Next are algorithms sort of put into parallel processing. So we're talking about, quantum computers and cloud computing, where we can almost exponentially scale up the computing resources that can be brought to bear on a big data set, like turning, speech into text. Another big one in the third spot here, guys, is graphic processing units, right, with fast matrix math. I don't know about you guys, but if you at all have built a PC in the last 3 or 4 years, it's amazing how much better, faster graphics processors have been. And they're many, many times more powerful than the CPU, the central processing unit that we have in our computers. So we're offloading to these boards, incredible fast matrix math that, allows us to render data really, really quickly, that doesn't impact the core processor, and it kind of takes that load away and allows us to, do parallel processing with a lot of data very, very fast with this hardware that just keeps getting better and better. And yeah, last but not least is the cloud. Obviously is a big part of our daily lives. Cheap and massive storage is now a click away. So we've got the data, we can store it, we can process it with parallel processing, we can put it across these GPUs. That's what has led to, speech recognition becoming so much better so quickly, and maybe not even something we've been thinking about. Because again, if we really lean into the cloud for a second, guys, there really is infinite functionality in the cloud. So I already mentioned speech recognition. There's also things impacting voice in our daily lives, like natural language processing, deep learning, and again, predictive analytics. We see it on the right-hand side. So when it all comes down to it, between the processing power and the cloud and all the different things that we're asking it to do, we can make things seem super smart, super fast now, and have it impact, the performance of everything from, again, the car that we're driving to the calls that we're processing. That's what we're going to get to here coming up. So, by the way, a couple months ago, Kelcor did a great webinar about what can AI do in the cloud for my contact center. This is one of the great slides from that presentation. Total shout out to those guys. Is, really now we have the ability to measure sentiment in voice. So we have software now that can measure intonations in people's voices. Large volume contact centers can actually detect the tenor, flavor, of the calls that are coming through the call center to measure sentiment. Whether somebody, you can see on the left, is not happy, or somebody is happy, and actually score sentiment. That's kind of been the next big wave coming through. All the different software tools that I'm using are sentiment measures, and now we can use software to measure that. We can also lean into things like intent, compliance, and verification. We can have, automated personal assistants. You guys may have heard Google's new personal assistant, where, in fact, I was actually offered it just yesterday by Google to turn it on our main phone number, where if we happen to be booking people for appointments, I think it works great for restaurants and sort of haircut places to start, where if somebody's calling and they're going to make a reservation with you or book a meeting, a computer can do that now, where it literally will understand what the person is saying. It'll respond as if they're a human being. You almost can't tell that it's a computer, but automated personal assistants are becoming a normal thing, part of our lives. And also, they really lean into sort of voice as insight and prediction too, to get people to the right places, write up those post-call summaries. And it's also, by the way, a great way to summarize calls in the contact center to do training and coaching. So again, this ubiquitous cloud storage with fast processing, natural language processing is really making a big impact on contact centers, really, and communication providers of all types. So let me take a step back here, guys, and let's start leaning into how this really applies to thinQ. So really, most businesses today rely on traditional technologies, right, like domestic, international, toll-free calling, and a lot of people are still kind of doing it like it's 1984. Most folks set up hardware to handle one route for their traffic, maybe two to have a backup. And then every 2 years, they negotiate with a big carrier like AT&T or Verizon. They make a volume commitment, pay a flat rate. And then, which again, I'm sure this all sounds familiar, and then they start to wonder, could I get higher quality calls? What if I could allow carriers to kind of bid for my calls and make sure that they're high quality vendors in the first place, and also get a better rate? And of course, the big question a lot of people have is, I don't want to lose any sleep over outages. I want to automate that. And because, if those carriers, or if that carrier or those two carriers, if I have a backup in place, go down, I go down. And last but not least, again, like it's 1984, if we have poor quality calls happen, what do we do then? Well, we had to file a ticket. We had to wait a day, 2, 3, 4 days for a response, and then 9 times out of 10 we're told, hey, it's okay, we fixed it, and you're all good, without really an explanation of what happened, what was fixed. So unfortunately, there's still a lot of people doing voice communications like that. But what I want to say now is, that was the 20th and kind of the start of the 21st century. Today it's 2020. So the question is there a better way? And of course there is. And now you can take advantage of what we were just talking about, the cloud and a flavor of artificial intelligence, machine learning, to better power your voice communications. And it's something you basically set it up once and it does that work for you, and make sure that you're routing the calls intelligently. And it just happens in the cloud with some great smart software. And really all it takes is a SIP trunk and an internet connection, right? So the good news is that, it's easy to get started. The cost of entry is minimal. And what I would like to say is, if you look at this, look at this infographic, is that, having the right cloud communication platform integrated into your business is absolutely critical today. So you can see on the left, I think we're all familiar with legacy kind of hardware systems. Nowadays, the cloud does that same heavy lifting, for you without having to have on-premise hardware. So now all of your carriers in your routing are online in the cloud. And, you can have it all managed by a third party, and you're the one who gets to choose, who gets your traffic. So you could spend less time than you ever had on call routing, and you can save really up to 70% on every call. And, yes, that's AI. And again, it's a flavor of it. It's machine learning that makes it all possible. And I want to show you guys exactly, how that works. So, today's communication platforms as a service, or CPaaS, I'm sure we've all heard that term, they all have the connection between machine learning and cloud communications, at their core. For instance, I'm going to show you guys thinQ's smart routing platform. It monitors your call patterns over time, and it gets smarter. As it gets smarter over time, it gets smarter in routing your calls the longer you send traffic through the platform, right? So as time goes on, it just gets better and better. And it analyzes your traffic patterns over and over again. And the more calls you get in a more distributed manner, the better. So the question is, how are today's platforms like thinQ getting smarter? Well, it's machine learning. So it gives our algorithms and our software the ability to learn without, specifically being programmed, to actually, get smarter. It's getting smarter because of that data over time. So at thinQ, the way that our system works and what makes it smart is that we update our platform several times a month with the latest price books and routes, right? So for more than 40 carriers. So that allows our platform to learn which routes among our 40 high-quality carriers cost the least to complete your high-quality call. So a lot of our partners actually save, about 60% on their calls, 50 to 60 in the first month, and gradually work their way up to 70% or more over time, right? It just optimizes that price over time. So again, what I just mentioned, the wider your call distribution pattern, the smarter your routing becomes over time, and the more savings you get, along, of course, with 40 layers of carrier redundancy to make sure you can sleep well at night. So as I mentioned, with this technology and 40 carriers en route, you have a backup plan at your fingertips that's 40 carriers deep. In fact, in this example, we just turned them all on. So if carriers experience issues or go down, you can explicitly go in and change your routing to avoid trouble spots in downtime. So instead of hearing that, somebody, in your call center, or, one of your customers says, I'm having trouble, with this number or this carrier, instead of filing a ticket and waiting, you can go right into the thinQ platform, find that exact, carrier, and turn them off for the rest of the day, for 3 days, for a week, forever. It's up to you. You could take people in and out of your system. And what's great about it is as your voice applications and services scale up and you send more traffic through the platform, there's no limitations. Again, it's a cloud system that's very smart, that has these 40 carriers en route. You get to decide who gets that traffic, who gets to bid for it, which routes the calls follow, and they're all high quality because they've been thoroughly evaluated by thinQ. So, and by the way, it's not only about sort of having a backup solution, it's also about, eliminating, PDD, or post-dial delay. So our technology also reduces the delay and powers an industry-leading call completion rate, especially for international. So again, if you have some smart software monitoring call quality and delivery, you can actually make changes to routing in near real time to make sure that the calls are, delivered at the highest percentage rate possible. So really, at the end of the day, we want you guys to have happier, customers, happier employees and partners, all the above, by using some smart software to eliminate some of these common problems. So again, that's really what a modern CPaaS platform that's powered by machine learning, can deliver for you today. And again, you can see here in this graphic, this is showing you exactly what's happening. A call completing from California all the way to the East Coast, and making a change to the carrier at the endpoint based on call quality, an outage, whatever it is, the software will intelligently route around it and find another carrier to complete the calls. Because at the end of the day, that's really what it's all about. So let's talk about ways to make your calls smarter. So the question is, how can this technology work for you? Well, the secret to it, as I promised in the webinar invitation, the secret to putting AI to work for you and finding out, what's going to make your calls smarter, all that data you already have at your fingertips, and the secret is it's in your call data. So we actually have the ability to let our machine learning take a look through, say, the last 30 or even 60 days of your calls and, think of it as a time machine for your January invoice, right? What if, thinK's machine learning algorithm has smartly routed your calls? Well, we can actually, with 3 data points, discover, how much smarter we can make your calls to deliver higher quality calls and also save you money. So the 3 data points that we need to look at are where's the call originating from, the from number, where is it terminating, the to number, and how long was that call. So this data that you can provide to us is right inside of your a CDR, a call detail record. And again, this data is entirely confidential. The raw data we can use is just sent through our algorithms to see the best route that every call could have taken with our platform to ensure high quality delivered through our 40 carriers at the best possible price. And we're able to actually send you back a snapshot of if you had completed those calls with us, it would have cost you X, and you can immediately compare, what you would have paid, with us versus with the system that you're using now. It's a real simple, easy way to put our machine learning to work for, your last set of calls to see what it would do. Let me give you a great example. So here is a very well-known, I can't say the name, very well-known U.S. travel contact center that this was from a couple months ago. They did over 3.6 million minutes in the month of data that they sent to us. Again, all we needed was the from number, the to number, and how long the calls were. And we actually figured out that if they had routed it through us, it would have cost them 007 for those calls. In fact, we were actually able to run this again with a more up-to-date price book, and actually it got down closer to 005, which was saving them a significant amount of money. With us, they would have spent $28,598, and they were paying more than twice that with their current, provider. So again, this is smart routing, made real with machine learning, powering those savings and quality, across those 40, different carriers. And again, by the way, just to make it clear too, this is pre-tax, right? These numbers are pre-tax, and again, these numbers change pretty wildly based on call distribution. So again, if your calls tend to originate and terminate in a very small number of states, or locations, that doesn't give the routing engine a lot to work from. But in this case, you can see here this U.S. Travel Contact Center gets calls from almost all 50 states. They're obviously based out there in California. So the wider the distribution, the more the software has to work with to change the outcome. By the way, this also works for international. In fact, you can see here, this was, we ran, a month of calls from a CDR from an international provider. You can see the map in the lower left where those calls were terminated. And we can see, based on country, how many minutes and how much they would have spent per country over the last 30 days. And again, this savings overall over their current carrier was, I believe, about 42%. If they had routed those calls through us. So again, this is very easy, very quick way to take a snapshot and actually see what the differences would be. It's right there inside of the data. Another big set of folks that we work with are people who work with systems like Twilio, Plivo, Nexmo. A lot of developers start with those systems and start routing, at first a small number of calls, and then eventually start ramping up those calls. They need more calls per second. They need more actual throughput. And the costs, especially with Twilio, add up very, very quickly. So in this case, we were super happy to talk to a provider who had more than 1 million Twilio minutes. They were paying, $15,000 to Twilio to complete those calls over a 30-day period. If they had come with us, again, pre-tax, they would have spent $5,000. That is a significant change. And it also, with our system, you also don't pay extra for the extra calls per second. And you don't have to set up another dedicated environment. It's a much simpler 60-second integration with a Twilio backend to route those calls through us to save money, get higher quality calls, don't drop calls, complete more calls. And it's an exciting part of our business that we've really leaned into in the last 2 years or so to help growing Twilio users still use Twilio for everything that they use it for, but just route those calls through thinQ to really experience some pretty incredible savings and allow them to scale and not have it negatively impact their cost of goods. Another example, of course, is Plevo. In this case, this customer had about 250,000 minutes or so. And again, it was basically almost a 50% savings, 46%. Same idea. Plevo is another player, just like Twilio. We took their CDR, ran it through us, and again, they can save a significant amount of money routing the calls through thinQ's machine learning-powered platform. And yet another example, by the way, guys, here's another Twilio user saving 57%, going from $3,000 to $1,290. And again, all this data is available to you. We can run the same report for you and actually see how much more intelligently we can route those calls with our system. So I hope that you all found a lot to love about those early examples to see how AI is impacting the present day. It's a big part of our lives now, and it's not just that Tesla that's driving next to you. The person might be asleep at the wheel, especially if you live out in Silicon Valley. It's a common sight you see on the message boards nowadays. This technology is getting smarter and smarter, but what I really want you guys to take away with is the value of machine learning in the products that you guys are buying for your businesses. Something like thinQ that's powered by machine learning, where we're uploading price books several times a month to make the software as smart as it can be. So when we're routing the calls through the carriers that are up and running and high quality, that you're getting the best possible price for every minuscule route. Our price books have millions of lines in them that we're updating several times a month. So it just means that we're making the machine smarter at spending your money in a better way to get a higher quality call that's completed more often. And it's really, really a win-win, and it's something where you turn it on, you set up, whether it's 20, 30, or all 40 of our carriers, and you have that redundancy, you have those savings, and it just becomes kind of an automatic, natural part of your business. You could put artificial intelligence, machine learning to work for your business today. So with that, Delaney, I'll toss it back to you. I'd love to answer any questions that people have about using AI, to power the present of voice.